I am going to start reading the caption on the bottom of page 17. The upward force caused by the rocket's engine is stronger than the downward pull of gravity. The rocket can lift off. What is weight? You probably think that weight refers to heaviness or lightness. You think of weight in terms of pounds or grams. But weight really has to do with force, not with mass. Weight is the amount of force that gravity exerts on an object. Weight is measured in units called newtons. To measure weight, scientists often use a spring scale. To use a spring scale, hook an object onto it. The force of gravity pulls the spring downward, and when the gravity exerts a large force on the object, we call the object heavy. And when gravity exerts a small force on the object, we call the object light. A spring scale measures the force of gravity on an object. We call this force of an object's weight. The amount of force that causes an object to move is also measured in newtons. Imagine that a soccer ball is rolling slowly toward you. You kick the ball away. Some of the energy of your foot's motion is transferred to the ball. Your kick causes the ball to accelerate. To accelerate means to change speed or direction, or both. The more force that is applied to the ball, the more the ball accelerates. Acceleration measures the rate of change of velocity. Remember that an object's velocity includes both speed and direction. Acceleration is measured in meters per second per second. m/sec for sec to the second power. A lighter object accelerates faster than a heavier object does. Motion of a soccer ball. Force applied in newtons. Then to the right, we have the acceleration. This table shows a clear relationship between force and acceleration. So if you take a look at force applied, you'll notice that 1 newton, the acceleration was 0.5. 2 newtons, acceleration is 1. 5 newtons, acceleration is 2.5. 8 newtons, the acceleration is 4.0. And 10 newtons, the acceleration is 5.0. What do you notice about this chart in terms of force applied and the acceleration? Well, you've probably observed that the least amount of force will cause the motion of a soccer ball to accelerate the slowest. You probably also noticed that more force that is applied to the motion of the soccer ball, the slower or the faster that it accelerates. How are forces and safety connected? The forces involved in accidents can harm people and property. To prevent accidents or make them less deadly, safety engineers learn how these forces work. Then safety engineers design products to resist these forces. For example, safety engineers must design car bodies that won't be completely crushed if the cars hit a wall. These safety engineers may put steel beams inside car doors to reduce damage in a crash. They may design padding to absorb some of the force of a crash. And to know how much protection is needed, safety engineers must understand the forces at work in a crash. Safety engineers design products that help to keep people safe and property safe. Why does this catcher need all of this protection? Safety engineers think about how many things that can help keep people stay safer. Think about skateboarding safety. Skateboarders wear helmets to protect their heads when they fall. Many helmets are brightly colored so that the skater can be seen easily. A chin strap keeps the helmet from falling off. These design features aren't directly related to forces, but they do increase skater safety. Safety engineering can mean many things. It can mean putting road signs where drivers need them. It can also mean making factories safer places to work. Look around you and think about all the things that help keep you safe. Behind all of them are safety engineers. Safety engineers design many things. They designed this factory to protect workers against accidents. How do forces work together? Well, forces are everywhere. They cause motion in a variety of ways. Two or more forces may act in the same direction or in different directions. For instance, when you throw a ball, your push makes the ball accelerate in a forward direction. Air resistance slows down the ball, and gravity makes the ball drop. How would you design an experiment to see how forces affect an object's direction? Here's an idea. Roll different sized marbles on a smooth floor and blow on them to change their direction. Try blowing in different directions. Blow harder or softer. Can you make the objects roll at different speeds? Throwing a ball involves many forces. These forces act on the ball in many different directions. Glossary. Balanced forces. Forces that cancel each other out because they are equal in strength and opposite in direction. Balanced forces exist when two sides pull in a tug of war and neither side can move. Force. A push or pull which may cause a change in an object's motion. An object moves when a force acts on it. Friction. A force that acts between two touching objects and that opposes motion. Two objects moving against each other create friction. Gravity. The force of attraction between objects, such as the attraction between Earth and objects on it. Gravity makes objects stay on Earth instead of floating into space. Unbalanced forces. Forces that cause a change in an object's motion because they don't cancel each other out. When a moving object changes direction, unbalanced forces have acted on the object.